I hope you all are well and enjoying this online session. Our today's topic is what is phase rule and what is phase diagram. So before we start our today's topic, firstly, let's take a quick recap to our previous lecture. What we discussed in our previous lectures, what is component and what is degree of freedom. So what is component? Component is the smallest number of independent variable. I give you an example of water. Water exists in three phases. Solid, matlab ice, liquid, water, and gas, vapor, right? But we can write only one formula. This is H2O. So this is called one component system, and it is denoted by C. Move on. What is degree of freedom? Degree of freedom is depends upon the variable like temperature, pressure, composition, or concentration. It is denoted by F. If degree of freedom 0, 1, 2, 3, we can say this system is zero variant, univariant, bivariant, trivariant, right? So let's start phase rule. What is phase rule? It is explain the equilibrium exists between the heterogeneous system, and it was theoretically deduced by Willard Gibbs in 1874 and studied further by H. W. B. Rumsum. It is also called Gibbs phase rule because it's discovered by Gibbs. This is the picture of Gibbs. So it is explained the equilibrium, and it is mathematically explained, not theoretically. So what is statement? If equilibrium between any number of phases is not influenced by gravity or electrical or any magnetic force or by surface action, but influenced only by temperature, pressure, and composition, then the number of degree of freedom F of the system is related to the number of component and the number of phases by the following equation. So what is the meaning of this statement? તો કે equilibrium between any number of phases not influence that means effect કે જેની effect માં નથી આવતું તો કે gravity electrical and magnetic force and surface tension but એ કેના effect માં આવશે તો કે temperature pressure અને composition તો એના પ્રમાણે equation શું બનશે degree of freedom component અને phase નું. Let's see equation P plus F is equal to C plus 2. So આપણે જોઈએ છે શું degree of freedom. So F is equal to C minus P plus 2 where you all know P is equal to number of phases present at equilibrium. C is the number of component needs to describe the system. That means this is one component system or two component system, right? F is the number of degree of freedom. Moreover, what is the limitation of phase rule? So it gives a limited information, right? It only gives the number of degree of freedom, but does not tell us that how much and in what direction the system moves to achieve the new sets of equilibrium. That means it gives only number of degree of freedom. એટલે કે bivariant છે, univariant છે, trivariant છે, but એ કઈ direction માં જાશે અને ક્યાં સુધી જાશે એ આપણને કઈ ભી ખબર નહીં પડે, right? Suppose we have water system in this ice, liquid and vapor in this equilibrium. If we change the temperature, the pressure will also change in order to have a new sets of equilibrium. Right? You all know if your temperature increase or decrease કરો તો pressure એની મેળે change થશે. But phase rule does not tell us how much pressure will be changed. એટલે કે કેટલા atm pressure change થયું છે એની કોઈ information phase rule આપશે નહીં. And what direction system would be moving અને કયું sets of equilibrium પહોંચશે એ બી કઈ information આપશે નહીં. So it only gives a number of degree of freedom, right? કે univariant છે, bivariant છે કે trivariant છે या zero variant છે. Now, phase diagram. What is phase diagram? There are two types of phase diagram. pressure temperature diagram and temperature composition diagram. So if the phase diagram is plotted between pressure and temperature, એટલે કે pressure અને temperature વચ્ચે જો ગ્રાફ ડ્રો કરવામાં આવે તો તેને P and T diagram કહી શકાય. It is used for only one component system. One component system, you all know water system, sulfur system. So PT diagram only for water system and sulfur system. Further, TC diagram. If the phase diagram is plotted between temperature and composition, એટલે કે temperature અને composition વચ્ચે જો ગ્રાફ ડ્રો કરવામાં આવે તો તેને શું કહેવાય? T and C diagram. And it is used for two component system: eutatic system, congruent system, incongruent system. We will later discuss about it. So this is the diagram of phase diagram. So depending upon the component present in a system, એટલે કે કેટલા component present છે એના આધારે બે types પડી શકે. કયા? તો કે for one component system and for two component system. હવે for two component system, component which react to form a compound, એટલે કે એમાં બે types પડી શકે કે જે component react કરી અને નવું કંઈ બનાવે તો એને શું કહેવાય? So this is called component which react to a form compound. And another one is component which are completely miscible but not react. એકબીજામાં મિશ્રણ થશે બરાબર, but કોઈ નવું compound બનાવશે નહીં. Now તો compound બનાવશે એવું કઈ છે? તો કે system having congruent melting point and system having incongruent melting point. I will later tell you what is congruent and what is incongruent melting point. Right? So, before we start our water system, you need to know this important definition, right? Sublimation, decomposition, melting, fusion, right? So what is sublimation? You all know sublimation, right? And when the substance goes directly from solid to gas. Like, for example, fill your ice cube trays with water, place them in a freeze, and the next day you will have an ice cube formed through a process called freezing. If you drop those ice cubes on a floor, soon they will have melted into water. So freezing and melting are two common phase transition, but sublimation is another one. Those for phase transition, we have a solid turning directly into gas. So this is called sublimation. There is a non-liquid phase here, directly solid to gas. So it is called sublimation. Another one is deposition, not decomposition. Here, this is my mistake. It is called deposition, right? When a substance goes a gas state to solid state, it is called deposition, and it is reverse of sublimation. એટલે કે gas નો directly solid માં થાય, right? What is melting? Melting occurs when a substance goes from a solid to liquid. I will give you example later. When a substance goes solid માંથી direct liquid માં તો એને શું કહી શકાય? Melting. Now fusion. Fusion is when a substance goes from a liquid to a solid state. Right? Liquid માંથી solid માં થાય તો એને શું કહેવાય? Fusion. This is the reverse of melting. Now vaporization, or it is called evaporation. This terminology you all are know, and you all are used in your laboratory, right? So what is vaporization? Is when a substance goes from liquid to gaseous state. Liquid to gaseous. This is called vaporization or evaporation. Now condensation. The substance goes from gaseous to liquid. It is reverse of vaporization. Vaporization માં શું હતું? Liquid to gaseous. Condensation માં gaseous to liquid, right? Critical point. The point in the temperature and pressure on a phase diagram where the liquid and gaseous phase of a substance merge together into single phase. એટલે કે liquid અને gas જે એક single phase જે એક પોઈન્ટે મળતા હોય એને શું કહેવાય? Critical point. And it is also called supercritical fluid. Now what is triple point? Occurs when both the temperature and pressure of the three phases of the system coexist in equilibrium. એટલે કે એક એવો point હોય કે જ્યાં ટેમ્પરેચર અને પ્રેશર બધું જ ઇક્વિલિબ્રિયમ કન્ડિશનમાં જોવા મળે તો એને શું કહેવાય? ટ્રિપલ પોઈન્ટ. So this is a fundamental information about melting. Melting, it is called solid into liquid. For example, ice cube melting into water. Melting is the process by which the substance changes from solid phase to liquid phase. Now freezing. Freezing liquid to solid, like freezing of ice cream. Freezing is the process through which the substance change liquid to solid. All liquids except helium undergoes freezing when the temperature become cold. Now vaporization. Vaporization, that means liquid to gas, means alcohol into vapor, or you can say evaporation. In this process, molecule undergoes spontaneous transition from liquid phase to gaseous phase. Now what is condensation? Condensation is gas into liquid. Like the process of condensation, water vapor into dewdrops. Drops જોવા મળે તમને, તો એને શું કહેવાય? Condensation is the opposite of vaporization. Any change in a state of matter from a gas phase to liquid phase. Now deposition. Gas into directly solid, right? And sublimation. Solid into gas. So this is terminology you can have to understand because you need to study our next topic, that is water system, right? So this is a diagram of this. Ice sublimate into steam, that means vapor. Ice melt into water and water evaporate into steam. In other side, steam desublimate into ice, also condense into water and solidify into ice. So this is all are connected together somehow. So this is a picture of we need to study, right? Thank you everyone.